Hello. Cool. We ready? Yes. One thumb up. Okay. 2, 3. Okay. Let's go ahead. What I'm going to talk about next is I'm going to touch briefly on web shells and what you can do with them real quick. So web shells basically just code that we're going to inject into a web server. So in this scenario, let's say someone has a terminal open and it's connected to a web server and you want to install a backdoor really quick on the web server that the user is logged. Let's say they're logged in as root and they left their terminal open, they went to the bathroom, and we want to see what we can do there. So what we're going to be using, so there's some things you can do with this on Linux servers. You can use reverse shells, and there's a lot of really cool reverse shell one-liners. I really like these. So we can set up our multi-handler, and then Linux we can go through and we just specify the callback address. And with the callback address, we can just call back to our multi-handler on the server itself. So with this one from pentestmonkey.net, basically we run this bash command. You put in your return address, and then what this will do is run bash like we had with netcat, call back to our multi-handler, and then we can run other stuff. There's ones in Python, PHP, Ruby. Here's netcat, Java, Xterm if you wanted to use Mac, other cool stuff. So this is a very, very basic web shell. And what this does is it basically just takes whatever's it passed into the get parameter and hands it directly to the system command and executes that command. So in our web server that we have on our Kali Linux, we can put in our web shell backdoor on the web server, and then curl to it, connect to it, and run commands and do all kinds of stuff. So here in this example, so I have the test get parameter, pass it to system, I pass in the command ls, runs the got here executable. We can see all the stuff that's running in that directory. I could run other bash commands, or I could do another reverse shell if I wanted a direct command terminal. But here's just a really quick, it's really easy. All you got to do is just one line of code. You could stick it in anywhere on a PHP application, and as long as it's executing before the get command is called, it'll run and you can do stuff. A really awesome out-of-the-box web shell tool is called Weaverly. You can use this to generate PHP backdoors. And it's kind of like the interpreter of web shells. And the cool thing is you can use Weaverly to install an interpreter too if you wanted an interpreter session as well. So here I'm just generating a Weaverly generate command. I say overdrive is the name of the password for the web shell that I'll connect to. And then this is what the web shell looks like. It's just a bunch of code that's been hidden and made hard to read. And then we basically take that web shell and we move it into our HTML directory. And then when we connect to it over Weaverly, we have all of our options. We can do ls and do all kinds of cool backdoory stuff. So next lab, we're just going to go through and generate a Weaverly web shell and connect to it and run it and play with it. So let's do Okay, see, super easy. I didn't even mess it up. I'm going to exit out. I'll walk through that again. Exit. Quit. Control C. Okay, so one quick overview. So I do Weaverly. So Weaverly is just installed on Kali by default. Generate name password I want to use for the backdoor. In this case, I'm setting it to SAINTCON. You know, the thing to keep in mind too is if the web server isn't running TLS, your password's going to go in clear text if it's running HTTP, so that's something to keep in mind. Ideally, you want to password protect your backdoors because if someone else detects them and finds them, they'll just use them, so you want to make sure you password protect them. So I do that, you know, and I just take a look at the file that I generated, which is that help.php backdoor. That's what the backdoor looks like. That's what the code looks like. Since I'm already in the var www directory, it's already set there and executable. So basically all I got to do is get this code onto that machine somehow so I can maybe have it download from another website or wget it, maybe clear the history and stick it in the web directory. So this is something dangerous to think about. Like, this is why you want to lock your computer. Why you don't want to leave your terminal open is because of how fast someone could just stick something in there if there was someone around you that you didn't really trust. And then once we have the web shell on there, we just connect to it, specify the path to the PHP file and the password, and now we have a connection. So we can ls, help, we could do a SQL dump, auto etc password. I think there's a command here to, yeah, backdoor interpreter. So we could go back here and create a interpreter session and get even more access to the system using interpreter. So you guys kind of get the gist of it. Control C out of it. And then we have our little web shell here that we created, and we can just curl here. And then through that command we curled, we were going to run ls pwd, we could curl, we could type all kinds of other stuff, download stuff, do a reverse shell, anything we can do but you're going to be running as the Apache user, which is www.data. So you kind of have to go through another privilege escalation path. But usually you can write to temp, maybe get something to execute the privilege escalation on temp and then get further access, or get interpreter installed and use that to leverage other things and kind of go from there. So if someone's logging in a web server and their console's open, you can easily get a backdoor set up and going within minutes. Anybody have questions on that? You guys want to do the lab or have time for the lab, or you want to keep going? I don't know if you got to copy all the machines and got everything set up in time. Yeah, I figured. Okay. So next we're going to be playing with Backdoor Factory. And Backdoor Factory was a tool that was written a while ago. The developer who wrote it, Secret Squirrel, I can't remember his real name, but anyway, he decided that he didn't want to code on anymore because this was a great tool because you could basically use it to take your interpreter and whatever and merge it into something else. And his plan was to see if I can figure out his name because I want to give him credit for this. Completely slipped my mind. But anyway, he wanted to write a tool where if anything came through clear text, like any binary, in real time have the binary get patched with code caves. And code caves are basically The end of function, there's kind of some padding that the compiler put in where there's just like a bunch of null bytes and a bunch of NOP operations. And you can actually inject code in there and inject backdoors. And so as binaries are being downloaded, his goal with this tool was to, see if he's got his real name. Midnight Runner, I guess, is his Twitter handle if you want to find out more information on him. Yeah, but he stopped maintaining it. Let's take a look at this. And basically his goal was to set up a process where you have something basically man-in-the-middle binaries as they come across the wire if they're in clear text. So you could take the binary, taking like interpreter, whatever malware is going to install, like you're downloading putty, you're downloading whatever, and you inject it while it's being downloaded in real time while they're getting little pieces, and you could get Backdoor Factory to do this. And so Backdoor Factory still works, but most antiviruses will detect the fact that you're using code caves and see that. But he's like, I could go through and rewrite it, make it so it's more antivirus bypassy, because this used to be great because you could just use it to bypass antivirus, wouldn't pick up. But he's like, I don't have the funding for it, and I don't really see a whole lot of benefit in doing it, so he decided to close. And you can see in his blog here, he kind of talks about that. But it's still something fun that we can play with. Close out all these others. So basically what you do, let's say, for example, like what is the thing everybody downloads in clear text and never checks the MD5 hash on? Putty, right? You want to get a Linux system, you're like, oh man, I need putty. I'm on a Windows box, let me go download it. So you can go here and backdoor your putty command. So it's come back down to like, with our David Hasselhoff exe, it's really hard to be like, hey dude, I've got this exe, will you run it for me, right? Like, hey. Used to be able to do this kind of stuff because they're like, hey, I made this game, I want you to play it, and I'd hand them over and they'd play the game, like, yeah, it was a really fun game, like, cool, thanks for the shell. But with this, you can, if you know that there's some binary that somebody's using a lot, you can inject your code with code caves, and it will run in the code caves of there, and the putty will still run and do all its stuff, and then your backdoor just runs in the background, and you get interpreter, and you get up and going. It gives you a little bit different type of way of setting persistence. It's a little bit more hidden. But basically, you just download Backdoor Factory, and you run it. You say, hey, here's the file. And they'll show you. You run the F and command and show. And that'll show you all the types of backdoors that it has that it could fit into the code caves. So all of these code caves, your file has to be of a certain size because there's only so much space in those code caves. Actually, I think I have a link here to like what are code caves. Maybe it's further down. Yeah. Thought I had URL. Maybe it was in the other slides. Anyway. So we use Backdoor Factory, go through and we select, hey, what am I going to inject into this binary? Went through, that one failed, but this command worked, I know. So basically I say backdoor, putty, reverse shell, TCP line. So I'm just going to do a basic TCP. I think in this one I tried to inject interpreter. It failed. The version of Backdoor Factory that was on Kali, I had to actually upgrade it from Git to get it to work. So that's why I Git cloned it here. Well, I mean, so the question was, is the one on Git working? It works in the fact that it will inject malware into the binary, but it's not working because anything you inject will immediately get caught by antivirus. So if they have any antivirus, Windows Defender, basic default install. They've done nothing. It'll still get detected and caught, and it's boring. But the concept, I think, is still valid. I think he would just need to update it to reconfigure the malware that's installed to make it harder to detect. So I think anyone could go in there and do it if someone wanted to take on the project. Something I find really interesting, and so my goal is to kind of get to the point, like, can I do all the stuff the tool's doing, can I do that manually, and then test, like, can I get it to actually bypass antivirus is my next goal. Because I love this tool. It was so fun. Because you could just take the binaries, stick it, put it on their putty process, and then you got a reverse shell every time they execute. Oh yeah, here's the link. So if you want more descriptions, more information, there's a really cool link here that gives you like a detailed breakdown of how code caves work and like what this is and where he's hiding the shell code. But anyway, yeah, there's a putty to set up the listener. So both Shakatanai, I can never say it correctly, but anyway, a lot of the Metasploit tools, they've all been detected by Windows interpreters. So I imagine either someone's working on a new version of all this stuff, or it's just going to be broken, and you got to figure out, you got to dive deeper and get into, more of the really learning AV bypass, really learning manual backdooring, and really learning antivirus invasion. In the old days, I'm really talking about like 2015. You could just use these tools and script kiddie your way through everything, but this is good, right? It's a good thing. Antivirus is getting slightly better. It's a good thing. I'm going to skip the demo on that. We can go through the demo later if you guys want to play around with it. So another really cool tools, backdooring tools, if you really want to mess with people, is you have your PwnPy and Poison Tap. And Poison Tap is super dangerous. And we'll talk about that a little bit later. The main thing you need to make sure is when you buy your Raspberry Pi, you get the one with the wireless adapter on it. If you don't, you can still get PwnPy, but the whole point of PwnPy is you connect it into a computer, and then you can connect over the wireless and control that computer remotely. So this is kind of my Pi I have set up. Yeah, you just stick in the USB drive and stick it, and if you can get a USB drive or you get it hidden, you can just stick it into the machine. So this one's like, with the PwnPy is more for like if you want a permanent wireless backdoor into something. Poison Tap is literally the finger of death. And that's the cool, there's a lot of setup with it because you got to get the web server set up, you got to get all the stuff set up. But basically with Poison Tap, you plug it in and it's going to completely, totally just own all the host files. It's going to try and do a bunch of stuff in the background. It goes through and tries to compromise the system as best it can, and then it reroutes all their web traffic and everything that they can through you in your web server. And it's completely transparent. It's pretty cool. But anyway, so also with the PwnPy, you can put Ducky scripts. So it's kind of like a poor man's Ducky. Are you guys familiar with Hack5's Ducky? So basically, it's just a USB drive you stick in, and it interprets it as a USB drive, or sorry, not USB drive, as a keyboard. So you stage a bunch of keyboard commands in there. Go to Windows, run command, do this stuff. Have it go and download your binaries, go through and execute your code and do stuff like that. I'll show you a little bit. Let's take a look at Poison Tap. You know what? I lied to you when I said I didn't have any audio. Well, I'll just describe it. So basically, this is just Poison Tap, and I want you guys to be aware of this. I provided links on here on how to set this up. So you can set it up like an Amazon or something like that. Pi0 is another module? At least I thought I did. Yeah, installing Poison Tap for Dummies. So this goes through and basically tells you how to set up the web server, how to do all this stuff. But basically, Poison Tap works by creating a fake networking device and then telling the operating system to route everything through that networking device. And it hijacks all the networking stuff. It goes through and runs, gathers as much cookie information it can, any passwords it can, any of that information, and then does remote accessible web-based backdoors, all kinds of stuff. So if they bring up a browser or they do anything with their browser, it's gonna intercept all of that and then execute backdoors and all kinds of cool stuff. Yeah, it's just a Pi0, the same thing. So the nice thing about this is you can just plug it in, let it run, and then walk away. That's all you need to do. But the other problem is if you're doing this as a joke, you've now really ruined your friend's computer. But it's cool. You just install it. So I'm just letting you guys know about that. I think one of these times I'll come down and we'll do a demo, maybe just do like a whole lab on just these tools and get the whole thing working. It does take a lot of time. Okay. Yeah, so the question is, you don't have to have the system unlocked. You can just plug in. Yeah, all you have to do is have an operating system. You need to make sure that you power down. If you leave, you power down your system, because someone could just walk by if it's in sleep mode, and it'll just go through and run and install the drive. And what it does is it installs the driver for the networking device, routes everything through that, sets all the scripts on the operating system, and then reroutes it to whatever web server that you have. So you're intercepting all their web traffic and rerouting it. So if they log into Facebook, Gmail, all that stuff, you're capturing all that. You're man-in-middle the whole system, and you just plug it in, let it run its stuff, and then in a couple of minutes, it'll have a complete compromise of the system. So the final module on here is just basically backdooring with SSH. So how many of you guys used the reverse shell with SSH? One person. Okay, good. This will be good. So SSH has the ability to bypass firewalls if you set up a reverse shell. And how that works is you run the SSH-R command. And so if you're on a machine, let's say you're working on a machine remotely, and it's getting late, and you're just like, I want to go for work from home, but the firewall, there's no firewall rule, there's no way to really get into the system. You can set up an SSH reverse shell from that system back to like another system you have in AWS, and then you can tunnel the SSH port through that system, through that SSH connection, back into that system, and then go back and do session commands. It's kind of a way to bypass firewalls. So using the SSH-FNR command, you can go through and just say, hey, I'm going to run in the background. I don't want to execute any commands. I just want to set this up and do a reverse port bind. And so I'm basically here, I'm saying, on the remote machine that I'm connecting to, let's say the server in AWS, I'm going to set port 4000. I want it to bind to the local host on the machine that I'm currently at, port 22, and then the user, and then the IP address of the remote system that I'm connecting to out in the web. To effectively do this, like if you wanted to automate this process, you just basically set up SSH keys on the machines, and then you can set like a cron tab to have it maybe run every day at like 5 o'clock, and it sets up a reverse shell. You know, you're going home, it sets up the reverse shell, dials into your box, and then you can jump to that box and reverse SSH in. You can also set up auto SSH. Auto SSH is a little bit more persistent, because if something goes wrong with the internet connection, or the TCP connection dies, there's really nothing to reinitiate the connection unless you have a cron set up or you're using auto SSH. If you set up auto SSH, you can SSH through the local machine, through the firewall, back to that system, and then if the connection dies, it'll come back up. And the nice thing about this stuff, it's all encrypted, and it's all transparent, and it looks like just a normal SSH session. There is a version of this on Windows. You can use Plink, Plink to set up SSH reverse shells. So if you set up, let's say you set up a backdoor on a system, you have a netcat listener, you have the netcat listener listen on local host, you can use Plink to SSH back to a web server in AWS, and then use that SSH port in the AWS to connect into the netcat and have the commands on the Windows machine. There's also my encrypt tunnels, kind of like auto SSH, does the same thing but for Windows. If you're going to do this in a malicious manner, obviously you got to make sure that the machine that is SSHing and doing the tunneling is your burn box, and you don't want to have anything that you really care about on that. And you need to lock that down so that because you're basically dropping a user account on that system that can SSH back into that box. And so if someone discovers that, they can go in there and be like, oh, I found this burn box. I want to, take control of it or whatever. I've got user access on it now. So you have to lock that down. And you can do that by setting the disable shell and then setting, just go through setting these commands on the remote machine, and then telling the login user that you're using for the reverse shell is no login. So if you don't want anyone that you have your reverse shell set up on discovering it and using it against you, you can lock down your machine that way. And that pretty much covers it for SSH reverse shells. So that covers everything I've got. So we can go through and do we can play with Backdoor Factory, see if we can get that to work, and see if we can get Meterpreter working. You can kind of see how it works. So let's go get Putty. All right, so there's our MD5 sum of our putty. And let's see if I've got Backdoor Factory. Cool. So let's go ahead and run Backdoor. Let's see if Backdoor.py was. Move putty to temp. Let's just try this. Okay, so we ran Backdoor Factory. We selected the cave. Let's say 1. Failed. home, the backdoor factory. That's where I put it. So that was trying to use the default installed backdoor factory. We're going to try the one from Git. That should work. Backdoor, cool. And we can see, no, it looks the same. 45.1. Oh yeah, I was going to save it as putty2, right? It's probably in that directory. Nope. Let's try it again. Section 1, maybe let's try section 2. Did it create a putty2? No. Saying restlessly, reverse show, we set the host, set the outback. Oh, I bet I'm looking in the wrong directory. It's in the backdoor folder. Ah, ha, there we found it. Okay, so we see that our hash has changed, right? That's a big indication that the file has changed. But if you look at the size 744, and then our clean version, oh. 757. So I guess it removed the size. Interesting. Usually tries to keep the file size the same. So it looks and feels like it's a normal binary. So let's copy our putty2 to our web server. And then set up a multi-handler. Yep, set it 77. Okay, we should be good to go. We have our putty terminal, it's all running, everything's cool. And then let's check our Cali blocks. Dang it. Set L host 33, set L port, run. Okay, now we're listening on the right terminal. Let's run putty 2 again. Didn't receive the session. Five, 6, 3, right? I am doing something wrong. Putty 2. Let's try running it just one more time. Let's select 1. This is basically just, again, selecting what cave we're going to be in. It's not too important. Putty 3. See if that's different from putty 2. It is. CD putty 3, var ww. Interesting. Well, I swear it does work. Yeah, they just have to open it. Yeah, just basically as long as the process is running. Let's turn Defender on and see if it detects it. I'm probably missing a step, is my bet. Because it should, once I do this, it'll freak out. Yeah, see, so there is something in there. Oops. Yeah, that should be everything, because we have the reverse TCP shell inline. Should go through and create a command prompt for me. Should dial back. But anyway, so you can kind of get the process, but obviously, as you can see, Windows Defender still found it, so the stuff doesn't work like it used to. But if you wanted to get more deeper into this stuff, it's kind of a good way to give you like an idea of how this stuff works. So, all right, cool. That kind of concludes everything I have for you guys today. So if you have any questions, feel free, and I'll just hang out if you guys want to do labs or whatever, or rework through other stuff. So, all right, thank you.